you're looking at the board here, we have a picture of a compass. You can actually see the numbers on the dial. This is so this is something that I wanted to talk about on how this works, okay? The compass itself points north, that's 0 or 360. If you go a certain direction, let's say east, that would be 90 degrees. And then as you go, you're still opening up this direction, the numbers get larger and larger. Until you hit south, that's 180. As you go to the west, that's 270, because you're still going around this direction. That's how the compass works. When you turn, the compass will still point north, and on a normal compass, there's little markers you can make to make sure that you have declination so you know which way you're facing, which way you're going to walk. So, how this works is we're going to watch a little part of a video that's going to discuss a certain group of people that are moving with a compass, and we're going to try to replicate the math that they're doing. Now, one of your group needs notes. One of your group needs the piece of paper I provided you. Another member needs a Chromebook. And another member needs a calculator.
I got calculator. Mr. Warren Joyce talked about calculator. I'm using my calculator.
What am I taking notes on?
I'll show you here in a minute.
I don't like the placement of that calculator.
Probably can't show the video because it's copyrighted, so I'll just put it this way. All right. Okay. So, on the website I'll have it. But I'm going to show you the video right now. Your person that has notes in front of them has to take the detailed notes of the numbers that are being said. And I'll play it a couple times in case you didn't hear it. It goes pretty quick. It's about a 2-minute clip. And then we're going to try to replicate the math, and we're going to try to solve out the numbers for it. Okay? All right. So, here we go. We're going to hit the link.
When you take notes.
All right, here we go.
Let's do it.
You're really good at it. Pay attention.
Like, what scumbags are they?
I'm trying to pay attention. You're distracted. You're not looking at
Hey, let's stop talking.
Yeah.
All right. Now, you're going to recognize the clip here. If you've been in history classes of Band of Brothers episodes from HBO.
Oh, yeah.
There's one particular episode, it's in the very first episode, where it's a 2-minute clip, and a lot of people just glanced over, they watched the clip, they just didn't think about it. It talks about some super, super intense math that these guys actually walk through. They just did it so fast that no one would catch it. So, here you go. And I'll show you kind of what they talked about and what we're going to do.
Band of Brothers.
Band of Brothers.
It's like a World War II
Yeah.
stuff.
Never put yourself off. Enter. On the last train jump, I had a compass. What happened? What? Yeah. Bearing 042, 12 minutes. Then another one. Yes. Yeah. Call it 358 for 10.5 minutes. Green light, right overran. Ramsbury. It's inclined. Linear distance.
Okay. We're going to watch it one more time. Okay, because it goes so quick that you wouldn't even catch the numbers. They're actually saying numbers on a compass, and you need to write them down in the times. So here we go.
Write them down. The last train jump, I had a compass. Can you turn it up?
That's about as max as I'm going.
Then you turn left. Yeah. Bearing 042, 12 minutes. Then another one. Yes. Yeah. Call it 358 for 10.5 minutes. Green light, right overran. Ramsbury, every single time.
Okay.
Right over
So
Rand.
let's talk about the numbers before we start so everyone gets the same notes. And again, we're going to watch it a little bit later again because we need to catch certain things that they're talking about. Because the first time you see it, a lot of people just glance over and you won't even think about what they're actually discussing. So first number that he said.
042.
What does that mean?
Northeast.
Northeast at what degree?
42.
42 degrees. Okay, so you should write that down. Northeast direction, 42 degrees. Okay? Second number,
358.
358. 358. And that would be what?
Northwest.
Northwest. A little bit. Okay, but there's two subtle words he said right before each of those. Did anyone catch the words he said right before
Right
each of
brand.
those numbers? What?
Fried brand, red brand.
No.
Right over.
I think somebody said?
Left.
Left. He said left both times. So the first one he goes left, going bearing 042, and then he said a certain time.
12 minutes.
12 minutes. You should write that down for the first time. So at 042, he traveled for 12 minutes. Then he said another left, going 358
For 10 and a half.
for 10 and a half minutes. Those times are super, super important. We're going to try to replicate the math here in a minute. What I'd like you to draw right now is a rough sketch of what he's talking about in triangles.
Like on this paper?
On your paper, down at the bottom, draw a rough sketch of the triangle.
Who knows how to do it? Because I literally have no idea how to do that. I have no idea. I don't even know what it looks like at this point.
So, draw your triangle, see if you can actually, see if we can get these numbers to make sense.
That looks right.
Hand this to him. Okay, I don't even.
Northeast, that's this way.
What was the northeast? You know that one fact I think every day you drink. Can you read it?
Yeah, we're gonna read it.
What?
I just don't understand.
Here's why. That was a good triangle. Holy crap. I bet it's wrong though.
I feel like it's two separate.
I have no idea
Probably
what.
like the northeast one was like the right angle and it goes like this and the north one came
What I need to
We're gonna watch the clip a couple more times, but I want to see if everyone can draw a rough sketch of what they're hearing, what they're thinking about when they think about these numbers.
Mr. Ward, is it two triangles?
Oh, one.
Yeah,
One
I'm
triangle.
lost.
Okay. Does somebody have a rough sketch and think they know what this is?
No. You want me to draw it on the board for you?
Yep.
A little shorter, so this is.
Okay. All right. Here we go. Let's see if you're correct.
Yeah, no.
Do you need your bag?
So,
Yeah.
started going.
Do you need your bag? Yeah.
Northwest.
Triangle. Okay.
Okay.
That was a good line. Well played. Was this one the 42?
Oh. 12. 10 and a half.
Not quite. You had the right idea initially, but your numbers are in terrible spots.
Terrible.
Okay.
12 goes with the
Let's talk about this, and then we're gonna go
Yeah.
through. So,
12.
nice attempt.
Oh.
Mark. Okay. All right. Here we go. And we're gonna get more detailed drawing here in a minute. This is just a rough sketch of what you should have. What does 042 mean?
42 degrees.
42 degrees. He said he was turning left. So if you had a runway, and we'll talk about this here in a minute. I'll talk about why it's a runway here in a second. You turn left. Left is that direction. Turning left, and you're going to go at 042. That means this number is 42 degrees on a compass from north. That's what he's doing. He's turning left, going 42 degrees northeast for how many minutes?
12.
12 minutes. 12 minutes. Then at that point, he said they turned again and traveled 358. 358 is doing this. That's 358, right? Well, that explains the words he said. He said they turn left, which makes sense that if you're going 042, this direction, northeast, and then suddenly you turn left, and your compass now says 358, that makes sense. You are turning left and going that direction, and that's why the compass says 358.
Wait, why is he doing this math since he's not on the phone?
Okay, so let's talk about this. Okay, what you're actually seeing a clip of here, okay? You're seeing a clip of just a couple officers getting together, trying to figure out on D-Day of World War II where they're going to be dropped off at. Because during this time, all these soldiers are being trained over and over and over to go through landing procedures. They train 3-4 times a day to go in the airplane, take off, parachute down to get training for this is the first time in war where we've used paratroopers before. It was first of its kind, and they were trying to see, can they survive the training? Will it work? Can they get to where they need to? Well, these officers were trying to figure out where they're going because the officers aren't told anything until the night before, so they don't want any information getting out there. Well, these gentlemen were putting together where you're going to be dropped off at, because if they're going to be in a realistic training, which they're doing multiple times a day, they're doing the exact same motions, the exact same time in the air, they're being parachuted off. Where they're jumping out at is the same distance from home on the real day they're going. So they're putting together these distances. That's why he said he went 358 and he went for 10.5 minutes, because that's taking him at a certain distance from home. That's taking him a certain distance from home, and that's the number they're finding. Now, they're doing very rough scales because they don't have calculators and other things, so they're just using compasses and shoestrings, but they have the exact right idea. They're doing the triangle stuff that you have been doing here, the stuff that you are actually working on. But they're putting it in a real-life situation. This is probably the most accurate form of math I've ever seen in a film before. And they're actually true. And what we're going to look at today is we're going to look at the map that they're using so we can see where he's putting stuff down and what he's talking about, because he does say certain town names, which I think some of you are starting to catch on to. And we're going to actually compare it to a real map and see, is he actually legitimately correct? Is he in that right ballpark of the numbers? Because a lot of people know this. Band of Brothers is super, super accurate on everything. They go down to the detail. They look at every note that every officer ever wrote, and they put it all into film. And they did it so accurately that this is a true life example of the numbers that were used. So, and I want to show you that. So, let's watch this clip one more time. So now, does everyone have a more detailed drawing? So, if you haven't drawn that, that's pretty accurate. Now, maybe not the 12 minutes and the 10.5, but that gives you an idea what the triangle is going to look like. And we'll discuss how we can actually find that number.
That's pretty cool though.
Hey, you haven't seen half of it yet.
We gotta
So,
watch the whole thing.
The
we are.
entire series is
All right.
I watch the whole.
Okay, we're good?
movie.
All right, I'm gonna stop the camera so we can actually continue the film, and then I'll restart it.
43.75,
Eventually, we'll do some form of law.
which makes
Law of
sense.
process.
Well, it's 50
Hey,
minutes,
something else.
10.5 minutes.
Okay, so if you were paying attention here, you take your 12 minutes, you divide it by 60 because we had to convert it to hours. So that was at 0.2. We took it times the speed of the aircraft that these gentlemen were in, and that gave me my distance. So this is a 50-mile journey before I turned and went 10.5. This is the number you had to find.
So
This
you want us to find B?
So, not yet.
Can we do it?
Not yet. We can't. Because we don't have the numbers inside the triangle that we need.
Right.
I'll explain here in a minute.
We have the angle side.
Yeah, we could just do some, can't we just do some simple trig functions?
We have two
and
The
find-
problem is the 42, this number down here, is not technically the number inside the triangle. It's going from north to there, not this piece down.
Well, you have the other one up there.
Oh, so you just
We have a
take,
part of it.
don't we
I'll
subtract
show you
it?
here in
Can't
a
we
sec.
just take 90, subtract it?
No, it's not 90. It's not 90. So,
It's hard. It's hard.
okay, hey, did somebody figure out the 10.5 minutes?
Yeah,
Please.
it's
All right, what do we get?
43.
I got 43.75.
Yeah, that's it. Dyslexia.
43.75. All right, talk me through that. Why is it
We
43.75?
take 10.5 divided by 60 times 250, and that equals 43.75.
And
Okay,
it makes
Miles.
sense because if the 12 minutes is 50 miles, 10.5 is smaller than.
smaller than that. So, okay, so what do we get when we took 10.5 divided by 60?
It was 0.175.
175. All right, and then you took that times your 250, and you got your 43. And if you didn't hear Josie here, that number made sense. It's smaller than your 50 miles because we went less time, 10.5 minutes. Okay, now the problem is we're almost done. We can almost replicate the math and actually figure out, is this true and accurate? Because I need to know this distance, and then we're going to put it on a map, and we're going to actually see it if it works. Okay? So to find this number, the problem is, and you guys are already starting to talk about it a little bit when we, some of you are trying to venture out the numbers here. The problem is, if I had this triangle like this, now this is the distance we're trying to find. We have, this is the 43.75. This is the 50 miles. The problem is, we don't have the numbers in the triangles. We don't have them. We only have 2 walls. We have enough information to find the angles though. I know a lot of people will go, well, where do you got 42 in the corner? 42 is doing this angle here. That's 42. It's not the angle inside the triangle. How you actually use the 42 is something that we have to review because it is a property of geometry, that in between the north lines, this north line on that compass, this north line on this compass,
They're supplementary.
these angles are supplementary. They're not equal, they're supplementary because the lines are parallel. The north lines are parallel, so these angles have to be supplementary. So if this is 42, that means this angle up here in the corner has to be a 138. Like this entire angle over here, the angle from north to there, because they have to add it to be 180. That's supplementary. The problem is, it's going from the north line all the way to here. That is not the number I needed. I needed from this spot and down, which is not 138. It's actually just a hair shorter than that. How short is it?
You have to do something with a 358, don't you?
358. If this is 358 all the way to here, what does that leave for this angle? 2 degrees. This angle is 2 degrees.
So it's
Because
136.
360 is all the way back to north. We were just a little bit short. So yeah, the number we actually needed inside my triangle was a 136. That's the angle that we needed. That's this angle right here. Now you're starting to see that this problem is a law of cosine problem.
Sass.
We have side, angle, side, and we can find the wall across from it. I would like you to replicate the math right now that we did yesterday. Find what letter D is using your group. I want to see the math on your paper, that you're actually doing the full-on formula. I have an example left on the board for you to help you out. Now that problem in particular, we found the angle, but you're actually going to be finding this wall right here, the 9 wall. So you'd have all of these numbers going across.
3.75 squared.
That's distance. Mr. Ward, is this right?
Plus, Z squared.
It's just a square wall.
Minus 2 times.
Oh, and then minus 2. Oh, okay.
Not a right triangle, we have a 136.
Times 50. Minus. Oh wait, times 50, yeah. Times the cosine of 136. So we can spell that 43.
0.75 squared.
75 squared plus 50 squared. Right below that, 4,414.1.
Do I take the square root of it out? Remember that?
2 times 4 should be 75. Times 50.
Times the. Oh, that's an angle.
Yeah, I know that.
86.9.
What is that equal?
That is not right, but okay.
Not the math.
We'll go with that. No, it's like 1,000 something, which is not right.
Yeah,
It's not 4,735.
Like 9,000.
It's less than 100 miles
I
back.
literally typed it in my calculator with like parentheses and
Because
everything.
if this is 43 and this is 50, this number has to be less than 90.
Oh yeah, I know that.
Cosine.
136.
Do you want to see how I typed it in my calculator?
Nope, I want to see it on paper.
I
can almost guarantee where you made the
literally wrote
mistake.
it down.
I can almost guarantee I know where you made the mistake.
Like
What?
that, I'll be.
Negative sign's probably wrong.
You subtract that from the
But that's okay. I'm
4,400.
glad that I understand.
4,414.1 minus what? 1,267.
I'll take the.
Is it 35?
Throw it away.
So,
I think I'll exit.
Well, yeah, that's
Wait,
okay.
Mr. Ward, I'm not.
Wait, it's something with our cosine being negative. Yeah, I don't know why, but. So, since it's a big number, it's gonna be a negative number, it's gonna be negative and a negative.
I just don't know what we're doing. Yep. Very good.
So we have to remove the number.
So I'm adding right here.
Yeah, make that a plus.
I actually, I'm making the cosine.
So what is the number again?
4414.1 plus 3, I mean 4375 cosine 136.
Let me just
No, still the same answer if I make it.
So the cosine.
You might be wrong on this one again here, guys.
Yeah, that
Wait.
sounds wrong.
It sounds wrong what you guys were just saying.
Well, we're gonna do it
Do you guys have it right?
Yeah.
Can somebody walk through, what do you have set up on paper?
Huh? Yeah, I'll tell you. Can I write it on the board?
No, tell me. Ella, what do you got?
D squared equals 50 squared plus 43.75 squared minus 2 times 50 times 43.75 cosine 136.
Alright. Okay.
That is the law of cosine. It's literally written on the board over
That's
there.
literally how it's written
Mr.
down.
Ward.
Do you guys
This
have
part.
it written down too?
This part is the part I'm worried about. Because when you multiply 2 times 50 times 43.75 times cosine 136, this number is negative.
It's positive.
So you're going to actually have a plus of whatever this number is.
Like you did that.
And that's the problem. This is where a lot of people would go wrong.
Is it 87? 86.9?
That's the number.
See, you said we were doing it wrong, we got it right.
And you're saying stuff is wrong.
Okay, yeah.
No, we
I
didn't.
still don't know why it is like
Well, guess what? Correct.
Okay. Apparently you just can't take it all in one.
And then what do you have to do last?
Square root it.
Square root. Okay, what was the number we're getting?
86.9.
Okay, 86.95. Now, to talk about this, before we actually get to the film, okay, I'm gonna show you what I mean by how to use this. Okay? So, all right.
They walked 3.3 marathons.
Okay, can you hit the lights for me, please?
Lars.
All right.
That was like a little question.
Okay. Hey, here's what I like you to look at right now. Yeah.
I did it.
Oh, Boris, just to let you know,
C squared.
Paul is not in charge of.
I know. I should have told you that last time. All right. Hey, real quick. Here's what I like you to watch. I'm gonna go to Great Britain here. All right. Now, I'm going to zoom in so you guys can see this. So if you looked at the map he was using, and we talked about if you actually looked at the numbers he was using, he had his finger about right here. That's where I was showing on the map a little bit ago. So in Google Earth, I can place a marker right there. This is roughly where his finger was. And I can draw lines. Well, when you draw lines using that tool, what it does is it tells you mileage when you actually click that ruler. So if I click right here, and I start drawing, I can actually see numbers. And this is roughly, now I'm a little bit off, it's actually I think a little bit further down. Let's clear that out. Figure that out. Alright, here we go. Let's click a little bit further south. There we go.
Yeah, a little.
And
You didn't click.
I would say a little further south.
okay. We're getting about 100, and that's not bad for the numbers we have, but if you actually watch what he does, it's a little bit different. So it's about 100 miles for that distance, and if you didn't know where this area is, and again, I'm a little bit off because I think they actually place their marker like here, like roughly, right there. And the idea is I can keep getting closer, but if I can't zoom in further, I lost internet connection. But what you're actually looking at is Normandy. So it's, it's Omaha Beach, and it's the other things, and that's exactly what you're going to see here on the film. And I thought this is just, it's insanely fascinating that they're so accurate on their numbers that they wouldn't even make up numbers like that. They made it accurate enough that it actually does work. I was only off by maybe 5-6 miles, but that would take me to the closer part of the beach. Okay, all right, I'm going to stop the film so you can see this.